Continuing from last video, where we learned about passing by reference, let's see a little bit how returning by reference works. As I explained, the way passing and returning works is pretty much the same. You pass a object, whatever it may be, a pointer or a variable or whatever expression, into a function. The actual thing itself will not be passed in, just its value will be copied over and assigned to wherever it's supposed to be assigned. And the same thing works by returning. The actual object is not returned from the function, rather its value is copied and returned to whatever it will be expressed. That value will be an expression wherever the function was called from. So let's have a look over here in our action function, where we declare that it will be returning a integer pointer. True to our word, we will be returning an integer pointer, which happens to be the very pointer that we got into this function by its parameters, and that we changed around a little bit over here by incrementing its value that is being pointed to. Now we take that very same pointer and we return it as the return value, which is supposed to be an integer pointer. So let's imagine that this pointer, of course, now contains an address which was given to it, the address of the variable y. Let's say that address is 00123456. Again, the pointer itself is not returned, but rather the value 00123456 is going to be returned to be expressed wherever the action function was called. So right now there is a memory address whose number happens to be 00123456 is being expressed right over here where we called the action function. And that memory address which is being returned is now being assigned to this pointer that we are creating over here. The point is that this pointer over here, ptr, in the action function, stays in the action function, and actually at this point it goes out of scope and it's being destroyed along with the rest of the action function, and it has nothing to do with the main function whatsoever. It's a completely different scope. However, what we did manage to do is to get a copy of the value of that pointer, which was returned to us from that function, and we use that value for our pointer that we are creating here. And when we do passing in such a manner by using pointers, even though the technical procedure of how stuff is being passed into a function and how stuff is being returned from a function is exactly the same as when passing by value, still when using pointers, this is called not passing by value, this is called passing by reference. Because though it is true that you are passing by value, the value of the address of that pointer, so in theory this should be called a regular passing by value, just like passing a regular variable into a function by value. However, because we are using pointers, and with pointers, as long as you got the correct memory address, you have full control over whatever the pointer is pointing to, then this is called with a different name, not passing by value, but rather passing by reference. So again, the system of passing stuff into functions and returning stuff from functions is exactly the same always, no matter what it is that you pass into the function and no matter what it is that you return from the function. However, we do have two different names depending on what it is you are passing into a function. If you are passing an actual variable, an actual object itself, and that object is being received into the called function as a plain old object of that same type, then we call this kind of passing by value, because this stays in his function and this stays in his function, and only the value is copied over and pasted or assigned to the variable in the called function. However, if you do this exact same thing, just that you are using a pointer, and as we will learn in the future also, if you are using a reference, we will learn what a reference is in a future video, then even though the system is exactly the same, it's passing by value, still we call it passing by reference, because thanks to the exact copy of the memory address that we received in our called function, we have complete and total control over whatever is being pointed to, as if we would have passed in an actual object into this function. Now this is all plain and simple when we deal with regular little variables and pointers to very basic types like integer and stuff like that. However, it gets a little bit more complicated when you will be passing around and returning objects of your own defined classes. I created a new header file over here in my project called monster.h, in which I declare a monster class with the declaration of the constructor, some function called attack, a few integer variables over here, and now I will include that monster.h header into my main source file. So now it's as if we declared the whole monster class in our file like we learned. Now over here I made a doStuff function, and over here I have the main function. Let's see what's going on. In the main function, first of all, I create an instance of my class monster, and I call it A. Now over here I'm creating another monster, calling it B, and then I'm using the assignment operator to take whatever expression comes out of calling this function doStuff and to assign that to monster B. So leave this aside for a second about how exactly the assignment operator works with objects of your own classes. What does it mean that I assign one of my monsters to another one of my monsters? For now, let's focus on calling the function doStuff and passing in the monster A into that function. As you see in the declaration of doStuff, we promised that the doStuff function will take in a monster object as a parameter, so we must pass in a monster object, and right now we are passing in A. As we learned, this is called passing by value, which means that we are not passing in an actual monster A which will actually be brought over to that other doStuff function, but rather the value of the monster A will be copied over and assigned to the object in the called function. Now that might be simple enough to understand with a regular integer, but how does this work with an object of my class? What does it mean that this object A is going to be copied over? What is its value that is going to be copied over and assigned to this monster over here? Well, the truth is that every class that you ever create in C++ will automatically have a few very important functions, even though you yourself did not make those functions. For example, every class will always have a constructor. Even if you do not make a constructor yourself, like I just deleted the constructor that I had before, the monster class will still have a constructor. The C++ compiler will create a constructor automatically for the monster class, because every single class in C++ must have a constructor, even though you didn't make one. Another thing that we will learn about is a destructor. Right now in our class monster we did not make anything called a destructor yet. We're going to learn about that one day. But the C++ compiler will make one for us, because we need it for any class. And one more thing that is automatically created for each class in C++, even though you did not make it explicitly, is something called a copy constructor. A copy constructor is a certain function in each class which is in charge of taking care of situations such as what we're doing right now over here, passing in one monster object which needs to be copied by value into a different monster object in a called function. If it's a simple integer or a simple character variable or something like that, then copying by value is pretty simple. But if it's one of your own classes, an object of one of the classes that you yourself created, then it's not so simple to just copy by value, which is why the copy constructor exists. The very basic job of a copy constructor is to go ahead and copy the value of each one of the member variables of this class, of this particular object, and assign that to the same variables in the object it's going to be copied into. So for example, in our situation, what the copy constructor will do, as soon as we call this function doStuff and we pass in the object A, the invisible copy constructor function is called. And what it does is, it will copy the health and the strength of the object A, and it will assign that to the health and the strength of the object X in this function doStuff where it was passed into. So again, as you see, the actual object A stays in the main function, and the monster X belongs in the doStuff function, and the actual A is not passed into the doStuff function. It is only copied by value because we are passing it by value using this object's copy constructor into the monster X object in the called function.